Hi everyone, my name is Hoàng Đình Thịnh and I'm a PhD student at the University of Toulouse. Today I'm extremely excited to present a live demonstration of StratoEye, open platform designed for integrating large language models or LLMs to comprehend conversations between pilots and air traffic controllers. The primary objective of the StratoEye platform is to evaluate the capacity of LLMs in its ability to interact with the API of any trajectory processing module. So in this demo, we'll use an in-house developed simulator. We call it the indigenous simulator. And hopefully you witness how the LLM could interface with various trajectory algorithms and pave the way for various functions like detecting misunderstood commands as well as surveilling aircraft movements. So today demonstrations is a little bit basic. We just have one aircraft, but we could show and convince you that we are capable of achieving this astounding level of language understanding with just 70 instruction samples. And we are actively working to extend StratoEye capability to not just work with our simulator, but also with other better known air traffic simulators like Blue Sky. So this is the map. I think is generated from the Cartopy maps. In reality, it should resemble more of a radar screen, but for the sake of demonstration, I think that should be sufficient. So I'm going to hit the little connect button right here, and you see that it's connected to the LM. And now we have one aircraft which have the call sign of Vietnam Airlines 19, is at 5,000 feet at 210 knots and heading 090. So what we're going to do is that, for example, with text-to-speech, we're capable of transcribing the speech command to text commands. So I'm just assume that problem is solved. I'm going to type in an air traffic controller command, for example, like Vietnam 19, turn right, heading 120. And you see that what's happening in the background is that the LM will try to generate the instructions, and then we parse these instructions and call the corresponding API functions. So the call is successful, and you can see that now the simulator expects our aircraft to fly a little bit to the southeast, heading 120, and we see that the pilot is responding well to the commands. So we're going to start with a more difficult demo. So for example, if I have a command like this on Vietnam 19, descend at your discretion to 3,000 feet. So you probably noticed that there are some words such as at your discretion, which will dilute a little bit of the command. And precisely, the large language model have never seen this thing before with the keyword at your discretion. So I'm going to hit enter, and we're going to see whether the language model will understand the command or not. So give it a little bit of time. Okay, so the call is successful, and we should expect the new target will be 3,000 feet, which it is 3,000 feet, and we see that the pilot is descending at the rate of 1,500 feet per minute to the target altitude of 3,000 feet. So in this way, because we know the target, we know we can infer from the speech data what the controllers are saying and what the pilots agree. The computers can actually survey and detect misunderstood commands or any kind of strange scenario that could threaten safety, and then allow the air traffic controllers to the unusual situation. So I think it holds the great potential to improve the general safety of the air traffic control operations. We are also working actively to extend, for example, to incorporate more diverse scenarios such as weather information, as well as some special other commands. For a deeper dive into this project, I would invite you to visit our website. And thank you very much for watching.